Imagine embarking on a journey. Not a journey across a continent, or even across our galaxy, but a journey through the fabric of space-time itself. You travel for 1,000,000 years, 10 million, 100 million. And for the entirety of that unimaginable span, you see nothing. No stars, no galaxies, no light. Just an endless, oppressive emptiness. In a universe teeming with trillions of galaxies, each containing billions of stars, such a place shouldn't exist. Yet it does. It's called the Boötes Void, a sprawling desert of darkness that stretches for nearly 1,000,000,000 light-years. It's a gaping hole in reality itself, a region where physics tells us thousands of galaxies should crowd the cosmos, but where only a handful of lonely survivors dwell. Is this a natural cosmic glitch, a scar from the violent birth of the universe? Or are we staring into the terrifying evidence of something or someone with the power to erase the stars? For decades, this anomaly has haunted astronomers, challenging our fundamental understanding of cosmic evolution. Today, we're going to dive into the dark heart of this great nothing. We'll dissect the scientific theories, from the plausible to the profound, and confront the unsettling possibility that the Boötes Void might be a shadow cast by a technology far beyond our comprehension. We are confronting the unsettling emptiness of the Boötes Void, a billion light-year expanse where physics suggests thousands of galaxies should exist, yet only a handful remain. We must dissect the chilling possibility of cosmic-scale engineering or early universe structural failures to explain why this massive, dark pocket of nothingness even exists. To understand the Boötes Void, we first have to grapple with its sheer, mind-breaking scale. Discovered in 1981 by astronomer Robert Kirshner and his team, the void is located in the direction of the constellation Boötes, the herdsman. But don't let the name fool you. This isn't just a gap between stars. The Boötes Void is a spherical region of space approximately 330 million light-years in diameter. To put that in perspective, the distance from our Sun to the nearest star, Proxima Centauri, is about 4 light-years. The diameter of our entire Milky Way galaxy is about 100,000 light-years. The distance to the Andromeda Galaxy, our closest large neighbor, is 2.5 million light-years. Now, take that distance, the gap between two galaxies, and multiply it over 130 times. That's the diameter of the Boötes Void. You could fit the entire Milky Way Andromeda system end-to-end across this void tens of thousands of times. But scale isn't the only unsettling thing. It's the emptiness. In the universe, matter is not distributed randomly. Through gravity, galaxies cluster together into filaments, sheets, and immense walls, forming a structure often called the cosmic web. In these filaments, the density of matter is high. Between them are vast regions called voids, but these voids are relative. A typical cosmic void might have a density that's half the cosmic average. The Boötes Void is different. In a region this size, standard cosmological models predict that we should find roughly 10,000 galaxies. But what do we find? Instead of 10,000, we have discovered only a few dozen. That's a density that's not just low, it's almost zero. It's less than 1% of what it should be. This isn't just a quiet neighborhood. It's a desolate wasteland where the lights are almost entirely out. The few galaxies that do exist within the void are scattered like isolated islands in a vast, dark ocean. They're often referred to as void galaxies. They are the sole survivors, the last outposts of normal matter in a billion light-year desert. Their presence makes the emptiness around them feel even more profound. It's as if we've stumbled upon a crime scene where almost all the evidence has been removed, leaving only a few strange, lingering clues. This specific region of space challenges our fundamental understanding of cosmic evolution, forcing us to ask, how does a hole this big even form? So, if it's not supposed to be this empty, what happened? The most widely accepted explanation takes us back to the very dawn of time, to the moments after the Big Bang. In its infancy, the universe was a hot, dense, and remarkably uniform soup of matter and energy. But it wasn't perfectly uniform. There were tiny, quantum-scale fluctuations, ripples in the primordial soup. These microscopic variations in density were the seeds of everything that exists today. As the universe expanded and cooled, gravity began to work its magic. Regions that were slightly denser than average began to pull in matter from their surroundings. Over billions of years, these regions grew, merging and accreting to form the first stars, then galaxies, then the vast clusters and filaments we see in the cosmic web today. This process of gravitational consolidation can be thought of like a soap bubble. Imagine a cosmic web of foam. The soap film represents the filaments of galaxies. The bubbles in between are the voids. Now, what happens to the smaller bubbles? They don't last. The surface tension, or in the universe's case, the gravitational pull of the larger, more massive bubbles and films draws the matter out of the smaller ones. The smaller bubbles burst, their walls collapsing into the larger structures. The leading theory for the Boötes Void is that it is one of these soap bubbles, but one that got an unusual start. The theory suggests that a minor, but significant, density fluctuation in the early universe acted as a kind of seed for a massive, galaxy-rich supercluster. This supercluster, as it formed, acted like a cosmic vacuum cleaner. Its immense gravity pulled galaxies, gas, and dark matter from a surrounding region that was already slightly underdense. It didn't just create a void. It cannibalized an entire volume of space, stripping it clean of its matter over billions of years. The few dozen galaxies we see inside the void today are the stragglers, the ones that were too far from the gravitational giants at the edges to be pulled in, or that formed later from whatever diffuse gas remained. From this perspective, the Boötes Void isn't a mysterious scar on the universe. It's a byproduct of its creation. It's the negative image of a massive supercluster. It's the empty bubble left behind after a galaxy cluster feasted on its surroundings. This is the most comfortable explanation. It keeps the universe neat, tidy, and predictable. But there are problems. If the Great Soap Bubble theory is correct, the galaxies inside the void should be a fossil record of this process. And when we point the most powerful telescopes of 2026 at them, they do tell a story, but it's a strange and violent one. These void galaxies are odd. They don't look like your average spiral or elliptical. They are often disturbed, their shapes warped by gravitational interactions. But the most surprising thing about them is that they are undergoing furious, accelerated star formation. They are birthing new stars at a rate much higher than galaxies of similar size in denser regions of the universe. This seems paradoxical. If a region is empty, where is the gas and dust needed to form stars coming from? The leading explanation points to a process called galactic cannibalism. The theory here is that the Boötes Void wasn't always a void. Perhaps, in the early universe, it contained a small, loose cluster of dwarf galaxies. Over time, these small galaxies, bound by their own weak gravity, began to interact. But unlike in the dense filaments where collisions are frequent and violent, these interactions were slow and inevitable. One by one, these dwarf galaxies were drawn together, merging into a single, larger galaxy. This process of total merger could have triggered the intense star formation we see today. When galaxies collide, the gravitational shock waves compress clouds of gas, causing them to collapse and ignite a firestorm of new stars. The survivors we see aren't just isolated islands. They might be the final products of a long, slow, cannibalistic feast that consumed dozens of their neighbors. The surrounding space isn't empty because it was always empty. It's empty because the matter was consolidated into these few remaining giants. But even this explanation has a haunting alternative. What if we're looking at the problem the wrong way? What if the Boötes Void isn't empty of matter at all? This brings us to the radical idea of dark matter structures. We know that dark matter, the mysterious, invisible substance that makes up about 85% of the mass in the universe, doesn't interact with light. We can only see its gravitational effects. It's possible that the Boötes Void is filled with a vast, invisible scaffolding of dark matter. Normal matter fell into the gravity wells of this dark matter to form galaxies. But what if, in this region, the dark matter structure was different? What if the gravitational wells were too shallow or too spread out to allow normal matter to coalesce into visible galaxies? What if, in this vast bubble, the dark matter exists in a diffuse, primordial state, and the normal matter simply never got the gravitational push it needed to ignite into stars? If that's the case, the void isn't a hole. It's a massive, invisible structure. It's a cosmic ghost. And the few dozen galaxies we see are just the dust motes dancing in a dark, invisible cathedral. It's a compelling, natural explanation. But for some, even the exotic nature of dark matter isn't enough to satisfy the profound emptiness. For them, we need to consider a possibility that moves us from physics into the realm of speculative philosophy. We are investigating the chilling theory that the Boötes Void isn't a natural phenomenon, but the result of advanced cosmic engineering on a scale we can barely conceive. What could possibly be powerful enough to hollow out 1 billion light-years of space? This idea brings us to the intersection of cosmology and the Fermi paradox, the unsettling question of why, if the universe is so vast and old, we see no signs of intelligent life. The 2026 perspective on this paradox is no longer just about radio signals. It's about looking for the shadows of technology on a cosmic scale. Consider the Kardashev scale, a way of measuring a civilization's technological advancement based on its energy consumption. A Type 1 civilization can harness all the energy of its home planet. We're not even there yet. A Type 2 civilization can harness the entire energy output of its star, often imagined as a Dyson sphere, a massive structure built to encapsulate a star and capture 100% of its energy. Now, a Type 3 civilization is a galactic empire. It can harness the energy of an entire galaxy, hundreds of billions of stars. What if the Boötes Void is the signature of a Type 3 civilization? What if, over millions of years, an intelligence advanced beyond our wildest imaginations systematically harvested the energy of every single star in that 330-million light-year wide volume? They wouldn't just build a Dyson sphere around one star. They would build a network of them, a Dyson swarm of incomprehensible scale. From our perspective, billions of light-years away, we wouldn't see their megastructures. We would simply see the light of those stars vanish. We would see a region of the universe that, according to natural physics, should be bright with the radiation of thousands of galaxies, but is instead dark. Is this a plausible explanation? The sheer scale is almost impossible to fathom. The engineering required to dismantle stars and build energy-collecting structures across 1 billion light-years would require technologies that border on magic. It would require a civilization to master not just energy, but space-time itself. However, the key point is that from our perspective, there would be no difference between a region emptied by natural forces and a region cloaked by a superintelligence. We are only seeing the electromagnetic shadow. The chilling 2026 perspective is that we can no longer dismiss this possibility outright. As our telescopes become more powerful and we begin to map the cosmic web in unprecedented detail, anomalies like the Boötes Void become places where the natural laws of physics meet the speculative possibility of intentional cosmic engineering. We are forced to ask, Are we looking at a cosmic glitch, or are we looking at the shadow of a god? Whether it was born from gravitational cannibalism, shrouded in dark matter, or engineered by an ancient intelligence, the Boötes Void might be more than just a curiosity. It might be a window into the ultimate fate of the entire universe. We are living in a special time, what the latest 2026 telescope data calls the golden age of visibility. The universe is still relatively young and dynamic. The cosmic web is bright with the light of active galaxies. But we know this won't last. The expansion of the universe is accelerating, driven by the mysterious force we call dark energy. As dark energy stretches the fabric of space-time, it pulls galaxies apart. The great clusters and filaments that define the cosmic web today will eventually be torn apart. The immense gravity that holds clusters together will be no match for the accelerating expansion on the largest scales. In the far future, trillions of years from now, all the galaxies not gravitationally bound to our own local group will have receded beyond the cosmic horizon. Their light will never reach us again. The Milky Way, having merged with Andromeda, will be a single, massive elliptical galaxy, adrift in an infinite, black, empty void. All the other galaxies, all the other clusters, will have disappeared. In that distant future, the entire observable universe from the perspective of that single galaxy will look exactly like the Boötes Void looks to us today, a vast, dark, empty expanse of nothingness. The Boötes Void, in this sense, is not an anomaly. It is a premonition. It is a glimpse of the inevitable fate of the cosmos. It shows us the destination we are all heading towards. The great nothing isn't a scar, it's a preview. So what is the Boötes Void? Is it a natural cosmic glitch, an oversized soap bubble from the violent dawn of time? Is it a gravitational ghost town, its matter consolidated into a handful of cannibalistic, star-birthing survivors? Is it an invisible continent of dark matter waiting to be mapped? Or is it something far more profound and unsettling? The shadow of a technology so vast, so advanced, that it has the power to consume the stars themselves? We don't have a definitive answer, and perhaps that is the point. The Boötes Void serves as a humbling mirror. It reflects back to us the limitations of our knowledge and the biases of our perspective. We look out into a universe that is mostly empty, and we stumble upon a place that is even emptier than the rest, and our minds race to fill it with monsters or gods, with cannibals or engineers. But the most chilling possibility may be the simplest, that the universe is just bigger, stranger, and more indifferent than we can possibly comprehend. The Boötes Void exists. It is a billion light-year hole in the fabric of reality. It doesn't need to be anything more than that to be one of the most profound discoveries in cosmology. It stands as a silent, dark monument to the scale of the cosmos and the tiny, fragile island of light we call home. Thank you for watching. If you enjoyed this journey into the great nothing, please like and subscribe to join us as we explore the deepest mysteries of our universe. We are only just beginning to understand the world around us, and the journey is far from over. In the comment section below, let us know what you think could have created this cosmic void. Is it nature or something else? We'll see you next time. Until then, keep looking up.